All right, welcome to lab number 3, mass movements. So we're going to be looking a little bit at different kinds of landslides that happen. And your first question, question 11.1, you are going to be figuring out how long it takes for a lahar generated from Mount Rainier to reach Tacoma, Washington. And you're going to be using that equation, distance equals rate times time. The question will give you the rate, basically the speed of the lahar. You will have to use this map to figure out the distance. Right here is your scale. There's where Mount Rainier, where the lahar will begin. We're looking at how long it takes to get to Tacoma. Just make sure you don't measure the straight line distance. Measure along the pathway the lahar would be following. So that's my clue for that one. Now, your next question on that lab is question 11.2. And this is another calculation. And it says, assume the following conditions. 1 cubic foot of dirt weighs 60 pounds. And then it says the average density of the grains in that comprise the dirt is 2. The porosity is 50%. And rainwater completely fills the porosity. How much is it going to weigh? Well, the thing that confuses a lot of people is this B thing, the density of the grains. And the reason it's confusing is it has absolutely nothing to do with the question. So what you want to think about is that you have a cubic foot, right? 1 cubic foot of dirt that weighs 60 pounds. And then you have half of that filled with water. And I gave you a little hint. It says the density of water is 62 pounds per cubic foot. So imagine how much does half a cubic foot of water weigh? And that should help you solve that problem. A few other questions in this particular lab. You have to measure the angle of a slope here, and you can use a protractor to do that. And then it asks you to tell me what the description of that slope is. Well, the descriptions are back here. So if you have a slope of 0 degrees to 3 degrees, it's considered flat to gentle. 3 to 8 is considered gentle to moderate, and so on. So that's how you read that chart. All right, other things in this, you are going to be taking a look at this map right here, telling you about this Los Leones landslide. And one of the questions, question 11.12, says, which of the kinds of slope failure illustrated in figure 11.3 on page 189 best fits the Los Leones landslide? Well, the key thing here to do is read the description of the Los Leones landslide right here. It says it was a chaotic jumble of earth that was mobile over the course of several days. So what that means is go back then to this page here where we describe the different landslides and find one that is described as a chaotic jumble of earth that moves over several days. And that should help you get the answer to that. Now, the last part of the lab, right here, questions 13, 14, and 15. If you notice, it says 11.18a for all of those. Well, let's look at what 11.15a asks for. I have to actually, it's 11.18a, sorry. So here's 11.18a. It says, identify the 3 natural conditions itemized by the Arkansas Geological Commission. Hint, All three are illustrated over here. So basically it's talking about a landslide that happened in Arkansas several years ago. And I just want you for 13, 14, and 15 to tell me what the three natural conditions going on that made a landslide likely to happen there. And that's my clues to help you with this lab. Of course, if you have any questions, just let me know.